Hi everyone. It's our second to our last section, the notes. Only 2 more new things to learn. This is a really fun section, and so is the next one. I think you'll like them. The first 2, a little dry. These 2 are fun. So this is exponential functions, something you'll do a lot of in Math 150. That's why I wanted to make sure we got this in before the end of the semester. So an exponential function is in the form f of x equals b to the x, so it has an exponent in it, but the exponent is a variable now. It's not a number. So that's how we know what an exponential function is. So if we had y equals x to the third, that is not an exponential function because the x has to be the exponent. So this is called a polynomial function. It's actually a cubic function. But this is an exponential function. So the difference is from what we've studied previously is now the exponent is a variable. So before our exponents were mostly 2, but sometimes we saw 3s. Now our exponents are going to be a variable, and they're called an exponential function. So they're saying the base b has to be positive, and it can be 1. That's because if it's 1, it's a straight line. So it has, because 1 to the anything is 1. So it just has to be positive, and it can't be 1. And the exponent can be any real number. It can be square root 3, it can be 5, it can be 8, it can be negative 7. Okay. Okay, so we have this. We can underline this. So the domain we're going to see, this is what exponential functions look like, and they do have arrows on both ends, by the way. The domain is going to be all real numbers, and that's because they go left forever and right forever, left forever and right forever. So domain, all real numbers, and we'll talk about the range in just a little bit. Okay, so everybody understand what an exponential function is? When the variable is the exponent, we call an exponential function. When the variable is a number, then it's a polynomial function. So here's some examples. Notice all 3 of these examples, the bases are positive, and the exponents have a variable in them. Variable x, 3 times x plus 1. So they all the exponents contain a variable. So those would all be called exponential functions. So in this section, we're going to learn about word problems that use exponential functions, and we're going to learn how to graph exponential functions. So first off, we're going to practice some calculator stuff. So round to 4 decimal places. So when you're taking computer tests, you have to make sure you pay extra attention, because when it's a paper pencil test, I can take a point off when you miss a decimal. But when it's a computer test, you'll get the whole problem wrong by not rounding correctly. So you want to make sure that you do round correctly. Okay, so this first one we're going to do 3, and it's an exponent, so we use the caret key. So caret, and then it's square root 2. So we do second x squared to get the square root symbol. Then we do our 2, and then we close it to tell the calculator that's the end of the exponent. So that gives us 4.728. And then we look at the 4th decimal. It's followed by a 0, so that means leave it 8. So our only choice is, does it stay 8 or does it become 9? And in this case, it stays 8. I'm going to wipe off my screen real fast. It looks like it's all smudged. Okay, for the next one, we have 4 to the negative 5. So we do it the same way. 4, then we hit the caret key, and then we do negative 5. And usually whenever it's a fraction or a negative, you should put it in parentheses to show the calculator all of that is the exponent. So 4 to the negative 5 would be 0.000. Whoops, nope, I shouldn't have done that. So 1, 2, 3, 4. So 9 followed by a 7 says make that 1 and that 0. So it's going to be 10. So 0.0010. So that would be it rounded to 4 decimal places. So the 9 followed by a 7 says make it 10. So this becomes 1. That becomes 0 because we can only have 4 decimal places. So 0010. And last, we have 5 to the radical 5 to the radical 6. So second squared to get the radical 5. Close that to tell the calculator that's the end of that radical. Then hit your exponent key. And then second square root 6. Close that to tell the calculator that's the end of the exponent. And so 1, 7, 8, 9. And it'll stay 9 because it's followed by a 3. So 7.1789. So that's how you use the calculator, because you'll need to know that because we're going to be filling in tables. So exponent key, in case you don't remember. And if you have fractions or negative as exponents, you should put them in parentheses. So as I said earlier, this is what our exponent graphs look like. So here's the exponential function. B, remember, is the base. It just has to be positive, but it can't be 1. And x can be anything, as you saw up above. We had x's that were negative, x's that were radicals. So if the base is greater than 1, so like this, y equals 3 to the x, for instance, we call that an increasing function, which is a big vocab word in the next class. Increasing means as you go from left to right, the graph is rising. So from left to right, the graph is increasing. It's a huge thing also in calculus. So always do it like you read a book, and if it's going up, that's considered increasing. So increasing functions are exponential growth functions. So you'll see in our word problems at the end how we're going to use exponential growth and decay. When the base is greater than 0 but less than 1, that means it's a fraction, so it's still positive. So that would be like y equals 1/2 to the x. So when the base is between 0 and 1, which 1/2 is, then we call it a decreasing exponential function. That means going from left to right, it's going down. A decreasing exponential function represents exponential decay. Okay? So base greater than 1, increasing, base between 0 and 1 is a decreasing function. Both of them, as we said earlier, have domain of all real numbers because they go left forever, right forever. Left forever, right forever. So both of them will have the same domain. Range, remember how we learned how to roll the pencil? The lowest y value is 0, but what we're going to learn later is it never touches 0 because there is a horizontal asymptote here that we're going to talk about on the next page. Oh, I guess we talk about it here too. And there's also a horizontal asymptote here. They're called y equals 0. Because remember from previous classes, whenever you have a horizontal line, because it only goes through the y-axis, it's y equals, and these are both right on the top of the x, so they're y equals 0. So the range is 0, but not including 0. So we use a parenthesis, and then they go up forever. Same thing here. Range is 0, but not including 0, and up to infinity. So you're probably asking, well, why aren't we including 0? Well, no matter what numbers we put in here, we can't get 0 with an exponent. So 3 to the 0th is 1. 0 to the 0th is undefined, so there's just no way to get 0. So we put these asymptotes in, and I tell students, think of them as like police tape. This is where the graph can get really, really, really close, but we can never cross it or touch it. So the graph just slides right along that asymptote, slides right along that horizontal asymptote. So without a number, like if there was a +1 here, then the asymptote would be y equals 1 because that raises it 1. But without a number added at the end, the asymptote will always be y equals 1, and it's called a horizontal asymptote. The function passes through the point 0, 1. How do we know that? Well, what's 1/2 to the 0? 1. What's 3 to the 0? 1. So you have to remember some of those exponent rules from chapter 4. Anything to the 0th power is 1. So the point 0, 1 will always be on the graph, and that's because anything to the 0th is 1. And that's saying there's no shifting. If we add numbers out at the back or subtract numbers or put numbers up there with the x, then that changes. But this is called the mother function without any shifts left, right, up, or down. And it will always have the point 0, 1 if there aren't any shifts in it. So anything to the 0th is 1. That's why the point 0, 1 will always be on the graph, as long as there's nothing added or subtracted out at the back. So let's put this into play. So, oh, look at that. We have one here. So first we're going to graph y equals 3 to the x plus 1. Does everybody agree that's an exponential function? Yes, because the exponent contains a variable. So usually I just do the basic table, -2, -1, 0, 1, 2, and if it doesn't give me any good points, or if it doesn't give me enough good points, then I can add some on at the end, because no one says you have to have at least 5, or just 5. You can always have more. So when I plug this in, this would be 3 to the -2 plus 1. Let's go ahead and write all the scenarios out. 3 to the -1 plus 1. 3 to the 0 plus 1. So I'm just replacing all the x's with these numbers. 3 to the 1 plus 1. 3 to the 2 plus 1. So this is 3 to the -1. Do you guys remember what that is from chapter 4? Remember how you have to reciprocate it in order to make the exponent positive? So it turns into 1 over 3 to the +1. So that would be 1/3. 3 to the 0th. In chapter 4, we learned anything to the 0th power is 1. And this one's been shifted. Remember, when it's with the x, it shifts it the opposite. So this graph is going to be shifted left 1. That's why the point 0, 1 isn't on the graph, because it's been shifted left 1. 3 to the 1st is 3. 3 to the 2nd is 9. And this is what I mean. Whoops, let's fill in these numbers. This is what I mean by sometimes you have to make, this is going to be 27, 3 to the 3rd. So that tells me, no, let's not do 2. Let's do maybe -3 instead. So 3 to the 3rd is 27. That was going to be too big, so I went on the other end and added 1. Okay, and we'll finish this up on the next video.